Good morning, afternoon, or evening, cats and dogs. Today's video will focus on the lesson 4.7 guided notes on the real number system. We've talked about a lot of different types of numbers this year, and we've actually addressed most of these already. So this is a good review for us to discuss the different types of numbers. We can divide our real number system. We do have imaginary numbers, something we don't talk about here, but you'll see in Algebra 2. But we divide our numbers into rational numbers and irrational numbers. Rational numbers are numbers that can be written as fractions, hence the ratio at the beginning or as part of that word. So any number that can be written as a fraction is a rational number. This includes fractions themselves, mixed numbers of course. It includes terminating decimals, which are decimals that end at some point, and also repeating decimals, which are decimals that go on forever but have a repeating pattern to them. Now we also have irrational numbers, and those are numbers that cannot be written as fractions. These are decimals that go on forever without a repeating pattern. A lot of square roots, for example, will be irrational numbers. Pi is an irrational number. It goes on forever and it doesn't have a repeating pattern to it. It can't be written as a repeating decimal in bar notation. Now, our rational numbers also have other types of numbers as subsets of those. That includes our integers, which are our positives and negatives, but no fractions included there. We have our whole numbers, which includes 0, but no negatives, so 0, 1, 2, 3, 4, 5, etc. Still no fractions there. And then our natural numbers, which is our smallest set. That's kind of what you learn to count with as a child. So starting at 1, no decimals, no fractions, no negatives, just 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way to infinity. So again, it's important to keep in mind a number is either going to be rational or irrational. Once it's a rational number, it could also be either an integer, whole number, natural number, or any of those as well. But if it's irrational, it can't be included in the set of integers, whole numbers, or natural numbers. And again, we talked about those numbers before, but it's been a while. So let's identify some irrational numbers here from our sets that we have. So each of these sets going across each of these rows has one irrational number that we need to identify. So in number 1, for A, we have the square root of 4. The square root of 4 is 2, so that's not irrational since it ends up being a whole number or an integer for us. 5.6 repeating, that's going to be considered a rational number because it's a repeating decimal with bar notation. Square root of 11, I don't know what that is off the top of my head, so no calculators for this, but my guess is if I plug in square root 11 to my calculator, I'm going to get a long decimal that doesn't have a repeating pattern to it. So let's look at D just to confirm that that is a rational number, which will tell me that C is irrational. So the cube root of 8, what I'm looking for is what number to the third power gets me 8. Well, that's 2. 2 to the third power gets me 8. That's an integer. That's a whole number. So I know that my irrational number here is going to be the square root of 11. So that's our irrational number. All right, let's take a look at number 2. So this row going across. So A is 5.8. You're going to excuse me. I'm also cutting some of my graded classworks at the same time. Always multitasking. 5.8 is a terminating decimal, and terminating decimals are rational numbers. B, 2/3. It's a fraction, hence it is a rational number. All right, let's take a look at C. Negative 0.3 repeating. It's a repeating decimal. That's going to be a rational number. D, cube root of 9. Now, if I said square root of 9, that would be 3, but the cube root of 9, there's not really a nice number that when you raise it to the third power gets you 9. In fact, let me plug that into my calculator and see what we get. We end up getting 2.080083823. Not really a pattern to that, at least not a repeating pattern. So that D, cube root of 9, is going to be my irrational number. All right, let's look at number 3. The negative square root of 64, well, square root of 64 is 8. Negative 8 is an integer, so that's rational. Square root of 75, I don't know what that is off the top of my head. It's not a perfect square, so probably going to be an irrational number. So if that number that's underneath the square root symbol is not a perfect square, then you can probably guess it's going to be an irrational number. But let's look at C and D and just confirm our guesses or our good thought here. So the cube root of 125, let's see, a number to the third power that gets me 125, that's 5. That's an integer, so that's rational. D, 2.856, that's a terminating decimal. That's a decimal that ends at some point, so that's going to be rational. So indeed, my guess is correct that the square root of 75 will be irrational. I'm going to calculate it just to show what it is. That's 8.6602544038. I'm sure it keeps going. We just don't have any more of those digits in the calculator. All right, so we're going to apply this a little bit. We're going to solve equations again, but this time these are going to be equations that contain square roots and cube roots. And we actually solved equations that contain square roots previously, so this is a short, easy lesson. It's something that we've done in the past. There's a bunch of examples typed up for you to take a look at. A couple of things that I want to stress before we get into our examples. So in example 1, we saw this when we did Pythagorean theorem before, so this is not brand new. But if I have x squared equals 121, the thing that undoes squaring a number is the square root. And if I take the square root of x squared, I get x. And if I take the square root of 121, I get 11. When we did Pythagorean theorem, though, we were doing sides of a triangle, and those had to be positive. However, there's actually two solutions to this equation, positive 11 and negative 11. So we use this plus or minus symbol that I'm going to quickly highlight here if I can. Let me grab my highlighter. This plus or minus symbol means that it's either positive 11 or negative 11, because positive 11 squared gets me 121, but so does negative 11 squared. Negative 11 times negative 11 gets me positive 121. So the answer to this problem is plus or minus 11, and that's when we solve an equation that contains x squared or a variable squared. In example 2, we want to isolate that b squared first. So I divided both sides by 4. That gets me b squared equals 36. Then I take the square root. And again, I get that plus or minus 6 here because we have two solutions to an equation that contains a variable squared. We can do the same thing for cubes, except instead of taking the square root, we're going to take the cube root. What undoes cubing a number is taking the cube root. The cube root of c cubed is c, and the cube root of 8 gets us 2. Now this one doesn't have a plus or minus. 2 cubed gets me 8, but negative 2 cubed does not. Negative 2 to the third power gets me negative 8, so there's not two solutions to that. All right, example 4, again, you want to solve or isolate that u cubed first and then take the cube root. I'm not going to go through every step because I know you can read that. We'll see some examples here in a moment. Example 5, we have e to the third power equals negative 64. Now, if that's at e squared equals negative 64, there's no solution within the real number system for that. There's imaginary numbers, but again, that's Algebra 2 content. But if we have something to the third power, we're allowed, or we are able to, as I'm combining two words together, we're able to take the cube root of a negative number. So when we take the cube root of negative 64, that's negative 4. Negative 4 to the third power is going to get us negative 64. You really should be able to do these problems without a calculator, and I'm not saying you can't use a calculator for these specifically, but you really should be able to do these. I'm going to keep the numbers pretty easy for you to do these without a calculator. All right, let's take a look at our example. So number 4, we have a squared equals 25. So the thing that undoes squaring a number is the square root. When I take the square root of 25, I get 5. But don't forget we get two solutions for this, plus or minus 5, since both positive 5 squared and negative 5 squared get us positive 25. All right, number 5, you want to isolate that x squared first. So divide both sides by 2 in this case. And what that'll do is get us x squared equals 81. Take the square root of both sides, and the square root of 81 is 9. Now keep in mind, two solutions for this. If you take 2 times 9 squared, you get 162, and 2 times negative 9 being your base squared, is also 162. Don't forget, if you're taking 2 times negative 9 squared, that negative 9 should be in parentheses since our base is negative. All right, number 6, moving right along. Feel free to pause the video at any time if this is going too fast and you need to copy it down. That can certainly help you. So we want to isolate that w to the third power. We're going to divide both sides by 3 first. That's going to get us w cubed equals 8. take the cube root of both sides, and the cube root of 8 is 2. Remember, negative 2 doesn't work here. Negative 2 to the third power gets you negative 8, and negative 8 times 3 is negative 24, not positive 24. So just something for us to keep in mind. All right, number 7, we have 5v squared equals 45. Let's isolate that v squared by dividing both sides by 5. That's going to get us v squared equals 9. Let's go ahead and take the square root of 9. That gets us 3. Again, 2 solutions here because 3 squared gets us 9, so does negative 3 squared. And 9 times 5 gets us that 45. All right, number 8, t to the third power equals negative 27. No need to isolate the t cubed, but we're going to take the cube root of both sides. The cube root of negative 27 is going to get us negative 3 because negative 3 to the third power gets us negative 27. All right, finally, number 9, let's divide both sides by 2 to isolate p squared. That gets us p squared equals 64. Take the square root of both sides, and our solution is plus or minus 8. So this is a pretty short and sweet lesson. We've seen the square root kind of stuff before when we did Pythagorean theorem a few units ago. The cube root stuff might be a little new for you, but I think it's pretty straightforward. Of course, this is new information, so you might feel a little uncomfortable with it. If you have any questions, don't be afraid to ask questions, of course. All right, so the last thing I want to take a look at here in this video, and I know I'm adding on to this video just a little bit, is a question that's not in your notes, but there's a question like this on your review sheet, and there's a question like this on your unit test, and it is related to the concepts we're talking about in terms of rational versus irrational numbers, and also locating their positions on a number line. So this question says that the following points are described below. Again, it's not in your notes, but I want to take a look at it anyway since it's a pretty short video. And we've got these 3 points. Point A, which is 5 over 2 pi. Point B, which is 7 2/3. And then point C, which is the cube root of 230. And it asks us to graph and label the points that are irrational numbers below. So we've got to graph these, but we're only graphing those that are irrational. So we want to identify whether they're rational or irrational first. Something to point out here is I would let you use calculators for a question like this because you don't necessarily know what these are as decimals off the top of your head. So point A, 5 over 2 pi. Pi is irrational itself, and if you multiply it by 5 over 2 or 2.5, it's still an irrational number. So we're going to graph point A. In fact, let's go ahead and calculate it. What I'm going to do is I'm going to take 5 divided by 2, and I'm going to hit equals. It gets me 2.5. Maybe you already knew that. I did too when I calculated it anyway. And I want to multiply that by pi. And that's going to give me an approximate value that I'm going to graph here in a moment. So I'm going to type this in. Let me grab my font here. There we go. All right, so this is going to be about 7.853. I'm going to put a dot, 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 just to show that it's about that value. So when I go to graph and label this point, let me put it right up there. There we go. Find a good position for that. When I go to graph and label this, I just kind of want to look at my number line here. So I've got 6, 6.5, 7, 7.5. Each of these tick marks is going to represent a tenth. So this would be 7.6, 7.7, 7.8. This is 7.9, so it's going to be about halfway between 7.8 and 7.9. So probably right about here, as long as you're in the right general vicinity. Now, if you have this point over here, that's a problem. Okay, if I have that point over here, that's above 7.9, that doesn't make sense. If I have it over here, that doesn't make sense. If I have it like right above that 7.8 mark, again, that's not really correct either. It's closer. We want it about halfway here between 7.8 and 7.9. So I'm going to label that point A. So that's where point A would be located. We want to be as precise as possible. Okay, it's really important for us. Now 7 2/3, that's not irrational. So I don't want to graph it. In fact, I'm just going to cross it out. It's not irrational. In fact, it's a ratio. It's a fraction, which by definition makes it a rational number. Cube root of 230. So when I plug this into my calculator, we should have talked about this in the last lesson, but I'm going to plug in 3. I'm going to find my x with the square roots key, which is above my upside down v. So I hit second and then the upside down v. I get the x in the square root key. And then I'm going to plug in 230, and that's going to get us about, I'm going to go ahead and type that in here, that's going to get us about 6.1269, somewhere around there. So let's identify where that is. Well, 6 is all the way on the left here. 6.1, 2, so it's going to be between 6.1 and 6.2, but closer to 6.1. So again, we want to be precise. If I have that point over here, that's a problem. That's less than 6.1. If I've got it way up here, really close to 6.2, that's a problem too, because it should be closer to 6.1. And if I have it anywhere else, again, that's not going to be precise. It's not going to be accurate. So 6.12 is not going to be quite on that 6.1 line, but it's going to be pretty close to that, and I'm going to label it point C. Again, we definitely want to make sure we're somewhat precise here. Now, we're going to see a little bit more practice with this. Again, I don't think this lesson itself is super difficult, but there's a lot of little things mixed in. So if you feel uncomfortable with it, that's to be expected for something that's new. But don't be afraid to reach out and ask, as I said before, because I want to make sure you're able to do these kinds of problems. Thanks for listening.